All right, let's take a look at WebAssignE6. Get this out of my way. Diagram above, we got a block starts from us at a height of 21 meters, so this is 21 meters. And the radius of this loop is 4.7 meters. And it wants to know what's the velocity at the top of the loop. So this is trying to play with you to see, do you understand how energy conservation works? Just because it's the top of the loop does not mean the velocity is the square root of gr. The velocity has to be at a minimum the square root of gr. This height is going to be 9.4 because it's 2r, twice the radius, the diameter of the loop. We'll call this position A. This will be position B. Energy at A has to equal the energy at B. So my potential at A, I don't have kinetic at A because I start from rest, has to equal my potential at B, my kinetic at B. So mgha equals mghb plus 1/2 mvb squared. For the 10 billionth time, Galileo was right, the mass will cancel out. GHA equals GHB plus 1/2 VB squared. From here, plug in the numbers, 9.81, 21, 9.1, 9.4, 1/2 VB squared. Algebra happens, 15.1 meters per second. So that's number one. Number two should look very familiar because it's right out of your notes. So if you want to see it, go look at your notes from for day 6. Number 3, skater starts at position A, comes down, friction is insignificant, and reaches position B, which is at a height 2.17 meters. That's H. What we're going to do, we're going to declare this to be a height of 0 because I can declare a height to be 0 wherever I want. And what that does is it makes the potential energy at A equal to 0. So I'm going to once again relate energy at A to energy at B, potential of A, kinetic of A, potential of B, kinetic of B. Now, just like I said the height of A to be 0, so there is no potential at A. Kinetic at B, that's the highest point, so at the highest point the velocity is 0. This quickly manifests 1/2 mva squared equals mgh for position B. Galileo was right, mass doesn't matter. 1/2 va squared equals 9.81 by 2.17. Algebra happens, VA is 6.52 meters per second. Onwards to 3. Biggest mistake people are going to make is they're going to go ahead and declare that the velocity here is 0. It is not. The y direction velocity is 0, but the x direction velocity has not changed. So we leave the ramp at 39 and has a speed at 37.4 at the top of the trajectory. So we even told you it was at the top of the trajectory. This would be position A, this would be position B. The energy at A equals the energy at B. I will once again declare my height to be 0 here. And I have an unknown height. That's what I am trying to solve. What this does for me is I get to declare the potential energy at A is 0. Do not think the kinetic at B is 0. It is not. 1/2 mva squared mghb plus 1/2 mvb squared. Once again, Galileo's right, mass cancels out. 1/2, the velocity at A is 39. It's given right here. 9.81, you are solving HB, that is the answer to your question. Velocity at B is 37.4, don't forget to square it. algebra happens, you get 6.24 meters. There you go.